All right, so the first thing is we are going to graph the following points. Points are always in the format of x comma y. As a review, this is your x-axis, so you always go left and right first. Then you're going to go up and down when you're plotting points. So 2, 0 would be located right about here. 2, 0. Okay, so the first one, this is a review for the benefit of everyone. You know this, just quick fill it in, that's fine. -5, count back 1, 2, 3, 4, 5. Then we're going to go up 3. It's going to be all the way up top here. Regular pencils, yep. Regular pencils for this. I'll tell you when you need the color pencils. 5, 1. 1, 2, 3, 4, 5, 1 is going to be up here. Sorry? No, you should be able to, it's in the first page. So right behind the first page. All right, and then the last one is -5, 1, 2, 3, 4, 5, and then up 5. -5, 5, looks like that. Not the prettiest points because it's electronic, but not terrible either. Okay, so the first topic of things that you need to know for this next section is plotting points, right here. Boom. All right, now, in that same vein, if we move to the other side, we're going to identify the coordinates, which means we're going to work in the opposite direction. We're going to write down the ordered pairs. So where would A be located? Down here in this bottom quadrant. 4 is an X. Then we went down to -4, so that's what we would write here. 4, -4. Ordered pairs are always in parentheses. How about point B? Perfect. -4, -3. C. What happens if we don't go left or right at all? 0, and then up 4. Just curiosity, does anybody remember the special name for points that lie on the y-axis? Remember what this is called? A y what? A y, starts with an I, intercepts. Any point that's on the y-axis is a y-intercept. On the x-axis would be x-intercept. We're going to do that in a later lesson, but I just wanted to see if you remember. How about letter D?
Letter D, -6, 5.
Perfect, -6, 5. Okay, so one thing that I want to sink into your brain right now is the fact that when we plotted points or wrote down the coordinates, which letter came first? X, okay? X is going to be your input value. Y is going to be your output value. We deal with this first. It tells us then, once we've dealt with it, to go to the Y. So think of the fact that X is a little more important right now because it's coming first. Right? That's going to lead us into the second part down here. First thing we have is the definition of a relation. So, first thing, relation. Okay? A relation is simply a set of ordered pairs. Okay? Set of ordered pairs. Every relation has two parts to it. It has the domain, which is your input values. Okay? So I'm going to put in quotes here. I'm going to say these are kind of like your X values.
That's what we make it.
Yep, your X values. All right? And then if it's not your x values, another way you could think of this as your input. I don't know why this is behaving so poorly today. It's also your input. The range is always going to be your y values. Or your output. All right, two things to know. I'm just going to say this verbally to save time. You can write this down. When listing the domain and range, first of all, we like to go list the numbers in order. That's the first thing. So from lowest to highest on a number line, we like to list them in order. List them in order. And the second is do not repeat numbers. And then you can put a little star by that one. All right, now I need to see all of these. All right, so under relation here, we're going to talk about 4 different ways to show a relation. A relation is a set of ordered pairs. That's what we defined it as. So we can do them as a list, which looks like this. We can do them in a table, which looks like this. We can do them in a graph by looking at the points specifically, the points in the graph, or we can do them in what we call a mapping diagram over here. And all you need to know is that you need to figure out that all of these should translate back to ordered pairs. There are different ways to represent ordered pairs. Yes, sir. But we're going to do them together, but I just wanted to make sure that we were sort of connecting the idea that a relation, yes, it's a set of ordered pairs, but we can show those ordered pairs in different ways. So, if I look at the first example, number 1, okay, this is where you can fill this in. This is going to be your list. So just write list. The one on the right is going to be a table. Underneath is where I'm graphing the points, so the points themselves are the relation. And the last is the mapping diagram. So yes, you can just write down the vocabulary word that describes what's being shown. All right, one thing to note here, over here, as this goes to sleep again. Okay, notice here I have 4 arrows, which means I have 4 points. The number of arrows tells you the number of points. All right, turn the page. All right, starting with A, up at the top, Identify the domain and range of each relation. Okay? This is where if you want to pull out color pencils, you are welcome to do that. Totally up to you. We're going to be consistent in what we're doing here. So I'm going to use red and I'm going to use blue. Okay? All right, so domain. Are going to be x values. Range is going to be the y values. So if I look at this example here, domain is going to follow x. It's always going to be what's first. So all of these are going to be my domain. I can simply abbreviate using the letter D. And I want to put them in order from lowest to highest, and I don't want to repeat. So which number repeats of the ones that I underlined? -5. So I only write that one time. -5, took care of that. Then comes the number 2, and then the number 5. I got it. Okay. So that's your domain. Your range is going to be the y values. So my y values are going to be here, 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 and here. None of them repeat, so I just list them from lowest to highest. 0, 1, 3, and 5. That's it. That's what they are asking you to know. So when the problem says identify the domain and range, what you, the student, needs to know is that when they say domain, they want you to list the x values. When they say range, they want the y, and they want you to use the 2 rules that we talked about on the front of the page. That's what you need to get out of this lesson so far. Letter B is, again, a relation given to you as a graph. My suggestion is always deal with ordered pairs. So if I look at this problem, how many ordered pairs do I have? 1, 2, 3, 4, 5? 5. Is there 6? Oh, at the bottom, down here, there's 6. So what I would do is I would probably make a quick list of 1, 2, 3, 4, 5, 6 points. Get my list of points and then go back and figure out the domain and range for this problem. Okay. So let's just work left to right, make sure we don't miss any. -2, 1, -2, 1, -2, -2. In the middle, you told me that 0, -4 was there. 1, -2. 2, 1, and 3, 3. I know, child's play. You get this. This is easy. Fantastic. We can do domain for this one. So my domain is not going to be this whole column, all the x's. Yeah, and what's nice is when I went left to right, didn't I put them in order? By accident? I mean, it sort of just happened that way. -2, 0, 1, 2, 3. Don't repeat. And then my range, this one's a little trickier. What is that? -4, -2, 1, and 3. And that's it. Those of you who did not pass or will take the keystone, they are definitely going to ask you domain and range questions. They are also going to ask them on the SATs. Those of you who took PSATs, does this look familiar at all? They would have asked you about domain and range. Good? All right, let's take a look at the next example. Example 2. You are welcome to keep using color pencils or not, up to you. Make a mapping diagram for the relation shown. A mapping diagram follows the same rules as when you report domain and range. You can't repeat x's, you can't repeat y's, and you draw arrows. So when I look at this, I need to have 1, 2, 3, 4 ordered pairs, which is going to give me 4 different arrows. So let's talk about the first column, which is x. Second, which is y. What are my x values unrepeated? Let's see, -1, nope, -5 would come first. -5, -1, and 3? All right, -1 and 3. There we go. My range is -10, -2, 2 and 6. All right, before we draw arrows, does anyone have a question about how I generated those 2 number sets? All right, then all I do is draw arrows for the ordered pairs. -1 matches up to -2. 3 goes with 6. -5 is going to go with -10. And 3 is going to go with 2. And I'm done. All right, why don't you try the next example? Since we did one, your turn to do one. You can do all one color. You could do color, domain one color, range another. Draw your arrows. I'll put the final answer up in about a minute. Okay, so you're doing the you do section. Kind of ugly looking. You put the numbers in order. Where's the button to put it to sleep? 5, top, up here. Oh, right there. Fantastic. Okay, we're going to take a little break from the notes for 1 second because I want to explain something that happens in Math World. All right, so have you taken biology yet? No? You've never taken biology yet? All right, do you know anything about chromosomes and babies? Yeah? So basically, you end up getting either this or you get this, correct? Which is a girl? Yeah, the Y makes it a boy, right? Yes? Yes. Okay. So in my head, because it was a long time ago, I don't think it's changed that I've learned this, the Y is what indicates that you have a boy. So when I think of ordered pairs, X, Y like this, I like to think of them as dating pairs. So this is X, meaning the girl, and this is Y, meaning the boy, and unfortunately in Math World, girls only date boys. That's not true of the real world. But there are relationships that exist in math world that are very true that happen in the real world. So let me give you my example. This is going to lead into this next definition, which is going to be the definition of define a function. Okay, a function. So let's say that I have a bunch of people in math world, and I'm going to say that 2 is dating 7, and 5 is dating 3, and 6 is dating -4, and these are all ordered pairs. Okay, this is my first relation. The question is whether or not this is a function. It is a relation. It's a set of ordered pairs, but can we further classify it as a function? So here's the test. Okay, looking at my girls. So we're going to call this the girl list. Do I have any girls that are cheaters? Which one? Do I have any girls that are cheaters? No. Well, you're going to say, well, what does it look like if they're a cheater? Here's an example of one that if they are a cheater. 1, -5, 6, -2, 1, 14. Here's the example of my cheater, right? Okay. So the definition of a function says, for every x value, they have a unique y value. What? For every x, there's a unique y. So really, the test is on whether x is repeated or not. This is an example right here of a girl, number 1, who is cheating with 2 different guys, -5 and 14. Okay? But here's the tricky part. This is a functional relationship. It's a functional relation. I have no girl cheaters. Here, I have 1 that is a cheater. That is not a functional relationship. Okay, well, what about this situation, miss? 2, -3, 6, 5, 9, 5. Who's cheating? The boy. But guess what? In math world, this is a perfectly functional relationship. That's how it is perceived in the real world also. Right? I mean, society, tell me I'm wrong, society kind of accepts this more than this. We've got way more choice words for those girls. But this is like, oh, it's biology. It's just how it is. He's cool for that. If a girl does it, there is something wrong with her. Think about it, right? So this is a place where math world, I mean, here's our cheater right here, but it happens the fact that this is the boys. So what I'm telling you is in math world, a functional relationship is when there are no cheaters or when boys are cheaters. If the girl is a cheater, that is not a functional relationship. Period. Okay? So when I explain this like this, and I do the same thing in my honors pre-calc, same exact explanation. They're like, oh, because your brain doesn't want to associate, like, why does it matter if one column matches but not the other? This is a stupid definition. It has to do with that underlying concept of what is functional. So I'm hoping that this will stick with you for the rest of your lives. When you interview for your job, do you know what a functional relationship is? You can say, yeah, it's when only boys cheat. No. I'm not condoning that. I'm just saying that that's how it exists in math world. So now if I can wake this back up here, and maybe click here. See? Math can be fun. We're going to move down here to our definition. Okay, a function, F-U-N-C-T-I-O-N. A function is a relationship in which every x has only one y. Which means, put a little star here, girls can't be cheaters. Please, if your parents or somebody ever sees this, and aunts, whoever, explain the whole thing. I'm not being sexist. Trust me. All right, so graphically, we talk about the vertical line test, right? Have you ever heard of that? The VLT? You can write that right here because I'm going to call it the VLT sometimes. The vertical line test, right? VLT? Who like a sandwich? Oh, Oh, I used to eat those twice a day when I was pregnant. Oh my goodness, I couldn't get enough. They were so delicious. They're bad for you? Vertical line test. Okay, now at the end of the day, if you take every type of picture and you go back to ordered pairs, you'll always be able to use that cheating analogy we used. The vertical line test is graphically. So take a look here at this picture. I'm just going to jump right down to this one. If I draw in this vertical line, do you see how it touches here and here on the graph? Remember, the graph is just the curve or the dots. It's not the axis. And if I look at that ordered pair, I think 1, 2, 3. This is the point 3, 3. This is the point 3, negative 3. 3, negative 3. My white girl floss. All right. Someday y'all are going to have to show me how this doesn't have to go to sleep so soon. Do you notice in my ordered pairs, my girl is the cheater? 3 is repeated. Okay, when you graph something and it's a girl cheater that repeats, they end up stacking on top of each other like this. I'm not going to go there with that. Just take it for what it's worth. That would be a fail of the vertical line test. This is a fail of the vertical line test. So we're going to say, no, this is not a function. That's how the vertical line test works. If I look here, this is just a list of couples or ordered pairs. Do I have any girl cheaters? No. So this is yes, it's a functional relationship. Yes, it's a function. No, it's not a function. Who's my cheater in part C? This is like X. This is like Y. Who's my cheater? This one. So this would be a no. This is not a functional relationship. You are asked to determine if it is a function. Is it a functional relation? Yes or no? Any questions on that? Girls can't be cheaters. Or rules of society that are different. All right, I'll let you copy that. I was kind of rushing a little bit there, so I kind of get excited when I get there. All right, I'm going to ask just because. Have any of you never seen this before? First time ever you're ever seeing domain-range relation. Okay. Are we at turn the page yet? Yes. All right, you try the U2 section. Up there at the top. Basically, you are analyzing, saying yes or no. That's it. The next section because it's the harder part. All right, what do you think? Yes and yes? Yes and yes? All right, so the big one, and this is why we put this in your notes, is the middle one. Have you ever seen a graph like that before? Okay, it has a name. It's called a hyperbola. Yep, it's hyperbola. Do you know how like y equals mx plus b is a line? So like when you graph it, it could look something like that, like a line. If I graph y equals 1 over x, a fraction where x is in the denominator, that's what's going to give me this crazy curved shape. That crazy curve is called a hyperbola. Now what you need to understand is this curve is going to continue to get closer and closer and never cross the axis on the left. It's going to get closer and closer and never cross the axis, the y-axis. I should. Amber, this is, where's Amber? All right, Amber, you've got 2 places to go. Come here. You're the nurse now. Find out what's going on with that, and then when you come back, there's this pass too. Okay, so as I was saying, this is going to get closer and closer and not cross this. The same thing's happening here. It's going to get closer and closer fractionally and here. There is no vertical line that I can draw that's going to touch the red at more than one place. Do you agree? Like, if I draw it on the axis, this never touches there and this never touches there. This is going to continue to kind of come down on this angle this way. So the answer to this is actually yes, it's a function. I cannot draw a vertical line that touches the red or the curved part of the graph at more than one place. It only ever touches at one point, no matter which line I draw. Anyone confused on that? You feeling okay? I'm almost done, I promise. You need your color pencils for this next section. So if you're asked to find domain and range, I think this is the hardest part of the lesson right here. You're going to write domain using these inequalities. I want you to turn these into boxes for me, please. Turn these into boxes. Where you're going to have to fill in 2 boxes. Okay? 2 boxes. All right, here it is. So let's take a look. I'm going to bring this first one up really big here. Okay? First of all, domain. Is it X or Y? Domain. X. Okay? So X is going to be domain. So I'm going to put a little note on this first one. X is going to be my domain. And the way it works is this. This is where your color pencil is awesome. How far left does this graph go? To here, right? So it's going to start here. And it's going to go all the way to here, like this. So how far left along X does it go? How far right? So this number gives me a 5. This number gives me a -6. Are we all good with that? I'm looking at left and right X values. My domain is going to be less than or equal to X is less than or equal to this. 5 goes in this box, -6 goes in this box. All right, this is your next one. Field trip. How far left? How far right? If I look at range, so this is my Y, this is going to be my range. How far down the graph goes is here. How far up is here. So what are the key numbers there? This is what I'm highlighting. 8 and -8. So my range is going to be 8 to -8. This is always the smaller or lower. That's what you're coming up with. This and this from this picture. This is a section where the colors do help. Domain is how far left and right. Range is how far down and up. Any questions on A? All right, I'm going to start rolling a little bit quicker now. Just a smidge. All right, let's go to B. All right, so here's B. Okay? Domain is X. So how far left does it go? To here. How far right does it go? To here. So my domain is going to be, this is -3, this is 3, is -3 is less than x is less than 3. That means any number between -3 and 3 will be in the table for x. Range is from here to here. This one's pretty obvious. So this is 5, this is -5, so my range is from -5, which is the lower one, up to 5. That's it. They don't get harder than this. It's just seeing it and understanding what your answer should look like. Domain and range from a graph are going to be written with these inequalities. Now, I made one error here. This is not the letter X. What letter is this for range? Y. Did I do that in the example before that? Did I write Y there? Okay. Just caught that, sorry. Any questions on B? Sweet, let's rock to C. As you can see, we can start to move a little quicker here. Yep, I feel the same way. All right, so how far left? This is what we're on the axis. So how far left do I go to 1? How far right? 6. So this is going to be, my domain is from 1 to 6. That's it. How far down? Stop here. Up to here. So that's from 1 to 7. All this. So my range is going to be 1 is less than or equal to y is less than or equal to 7. Done. Make sure you indicate which of your inequalities is domain and which is range. All right, 3 minutes to do 3 problems. Ready? Thumbs up. Do you notice that on the ends of these I have solid dots? Do you notice that the end of this has dots? Yes? Okay. The next type of problems on the bottom line are not going to have dots, they're going to have arrows. So that does change the domain and range because they are not, they don't end. So notice I don't even have anything on the x-axis anymore, right? This is going to continue. Do I have a biggest x value or does it keep growing? Keeps growing, so make this an arrow. What about over here? Do I have a small or does this keep going out to the left? So I have an arrow here. Anytime you have an arrow instead of a point, this is going to indicate positive infinity to the right and negative infinity to the left. So when I write my domain and I have my boxes less than or equal to x, less than or equal to, first of all, this changes because we can't have an equal sign. It's a long story, why not? But at the end of the day, infinity is not a specific number. The biggest number is infinity, the smallest is negative infinity. Yuck. These are those special cases that always exist in math. This is one of them. How far down does the graph go? Does it stop? No, so I have an arrow. This is negative infinity. How far up? Positive infinity. So my range is going to be the same. Negative infinity is less than y is less than infinity. Arrowheads mean infinity. That's something new today. Have you seen that before? Infinities. Yeah? Okay. Infinity. Any questions on D? Sweet. Let's go to the next one, E. E is a combination problem. It's got both. Take a look. It's got arrows, but then it also has a finite ending to the graph. So if I look here, this is a dot, because it doesn't continue to go to the left, but it continues to go to the right. What is this number along the x-axis? 0, okay? And then what's the biggest number to the right? Infinity. So my domain is 0 is less than or equal to x is less than infinity. The infinities can't have the equal sign. They cannot. All right, now how about range? Is this going to keep going down, down, down? What do you think? Down, down, down? Negative infinity it is. Negative infinity. How about this one? Up, up, up? Positive infinity. So now my range is going to be the negative infinity is less than y is less than infinity. All right, I would like you to try the last one. It's a combo problem. It'll have definite numbers and it will have infinities. All right, try the last one, domain and range. Last one. That should be your thought process. Can you translate that into the inequalities? Domain, how far left, how far right? Negative infinity? Doesn't this continue to grow out and up and up and up and up? It's going to keep making this get bigger. It's actually smaller. What about this way? Does this keep growing out this way? So x is going to continue to get bigger. There's your infinity. There's your negative infinity. What about y? How far down does it go? How far up? Positive infinity it is. So down is going to be 0. That's why I have an equal sign. But when I go to right infinity, notice there's no equal sign.